Hello, this video is going to show you the steps to create a project, create block diagrams, assign the pins, and then compile the project. This is the typical flow of Quartus project. Okay. First, you need to get the user menu for the board. This is the address, and this is the PDF of the user menu for the board. After downloading the PDF file, open it. It looks like this. Okay. Today, we are going to build a circuit with 4 inputs, 1 output. We will connect the 4 inputs to switches on the board and 1 output to the LED on the board. Okay? So look at table of content. Chapter 3, you can find the information about switches. So you click, scroll down, you can see there are 10 switches available on the board for you to use. The first one is SW0, the last one is SW9. Okay? And there are 10 LEDs on the board. LED R0, LED R9. Okay? Each switch has a dedicated pin. Each LED has a dedicated pin. When you use these components, you must connect them to the right pins. Okay? So let's open up Quartus Prime and restore the project we created from the previous video. So to restore the project, you click File, Open Project. Okay. Go to Local Disk, 2001, Hardware, Example 1. That's the project. Select Open. Okay, so the circuits that we're trying to build today, we have 4 inputs. Okay, we have the AND gate already in the schematic or block diagram. We need 2 NOT gates. So you click the symbol tool, you find under primitives, logic, scroll down, NOT. You need OK, 1, 2, press escape. So these are the 2 NOT gates we need. We need a 2 input NAND. Okay. Escape. We need a 2 input OR. Escape. We need a 2 input NOR. Sorry, we need a 2 input OR. we have the NOR already. So here is a 2 input OR. Okay. So follow my connections. The 2 input NOR goes here. NOT goes here. AND goes here. NAND goes here. The NOT goes here. And finally, the NOR goes here. Okay. So I place the components at the right place. We're going to wire them. To do the wiring, you need to use the wiring tool, which is this button here. You click, you can start wiring using left mouse. Press and hold. Press and hold. There is the first connection. Okay. Press and hold. Press and hold. Press and hold. Press and hold. So these are all the interconnect between all the gates. Next, we need to wire up the inputs. So in general, we call the inputs A, B, C, D. And the A, B, C, D will connect them to switches. Okay. So the first one, we want to get the input. The input are called pins. You press the symbol tool, scroll up. Under pins, you can have input pins or output pins. So input pin, we need 1, 2, 3, 4. 4 inputs. Escape, we need 1 output pin. Okay. For output, in this case, we name it Y. Double click the pin, change the name to Y, uppercase. Click OK. Right? Inputs, we name them A, B, C, D. So the first one is B, double click, uppercase B. OK. Second one, uppercase C. OK. Uppercase A. Last one, uppercase D. Okay. Once you finish changing the names for your inputs and output, what you need to do is you need to update the graphics. Okay. To do that, right click empty space, update symbol or block, click OK. So now all the graphics are up to date. So the circuits, D goes to the NOT, B goes to the 2 input NOR, okay. C goes to the 2 input NOR and the 2 input NAND. So this dot means there's a connection. If you don't see this dot, that means there's no connection. A goes to the NOT. Finally, we connect the output. Right? Let's do a file save project. So everything is saved. Next step, we need to go through the analysis and synthesis step. So the software will check the connectivity for you. If you have any error, such as unconnected input, shorter input, shorter outputs, you will see error messages. So double click the arrow. Okay, we have no error, but a few warnings. That's okay. It's green, that means we passed the check. So now you need to assign the pins according to the user manual. To do that, click Assignments Pin Planner. The pin planner has many windows. The only windows that you need is this window and this graphical view of your device. You can close other windows. Okay? So here you have everything in tables. You have name of your input, name of your output. You need to assign the location according to the manual, and you need to adjust the I/O standard according to the manual. Okay, so let's start with the output Y. If you look at output, we are going to use LED R0. So LED R0, it's pin 8, A8. So you click here, type in A8, enter. Okay. I/O standard 3.3 volt LVTTL. So click, double click, you see this list, you find 3.3 volt LVTTL. Select and click. Input A, B, C, D. We are going to connect A to switch 3, B to switch 2, C to switch 1, and D to switch 0. So switch 3, it's A, C12. Under location column, type in C12. B, D12. C, C11. D, C10. I/O standard 3.3 volt LVTTL. So double click, scroll down, 3.3 volt LVTTL. Double click, scroll down, 3.3 volt LVTTL. One more. One more. Okay. There's no save button in this window. Everything you do here will be saved automatically. So once you finish everything, you have to double check location, I/O standard. Then you can close this window. Close. Back to your project. Once you will have assigned all the pins, you can compile the entire project. To compile the entire project, you double click this arrow. It's going to go through the process of compiling everything for you, including your pin assignments. Okay. So the compilation of the project was successful with no error or some warnings. So you click OK to confirm. So make sure that everything is green. Then you can test your circuits on the board. We will create a separate video to show you the steps to create waveforms. Okay. So now take out the board, take out the USB cable, connect the USB between the board and your computer. The USB will provide power to the board. The moment you connect the board through the USB, the circuits will load. It is the circuits provided by the manufacturer. Okay? It is not your circuit, it's the manufacturer default. So now you need to download your circuits on the board so you can test your circuits. Okay? Every time you unplug the USB, you erase your circuits, and the manufacturer default will appear every time you reconnect the power. Okay? So go to Tools, Programmer. In previous videos, we have already set up the USB blaster driver. So now, under Hardware Setup, you should see USB blaster. Double click, close. Under File, you should see your project. In this case, EX01 is the circuit you use. Check the box, Program. This device should match your project. It is 10 million 10,050,000 DAF4A4. Click the Start button. The software will download everything to the board. Sometimes you'll see a message fail. It's because your USB cable is not straight. So try to make the cable as straight as possible and try it again. Okay? Start. And the progress will go from 0 to 100. Okay? 100 means everything has been downloaded. The circuit you just designed is loaded onto the board. Now you can toggle the switches to test if the circuit works. So if you look at the user menu, if your switch is in the down position, it means 0. The circuit in the up position, it means 1. For LEDs, if the LED is on, it means 1. If the LED is off, it means 0. So please go through all the combinations to test if your circuit works. So this concludes the design flow in Quartus. There will be a separate video to show you the process to create the waveform. Thank you.